Hi everyone, thanks for taking the time to watch our on-demand video on OneSpatial's work with 3D data quality integration and enhancement. For those of you that I've not had the pleasure to meet yet, I'm Kevin Sigwart, the Chief Operating Officer of OneSpatial Inc. OneSpatial Inc. is a U.S. company that is a fully owned subsidiary of OneSpatial Group based out of the U.K. OneSpatial focuses on data management solutions, and today we're going to be focused on some of our work with automating and the management of 3D geospatial datasets to support your work in the future. As technology continues to evolve to support things like smart cities, digital twins, and next generation 911, it has become more apparent that data quality and cleanup is becoming too daunting a task for a manual process. Adding to the complexity is the support of three-dimensional use cases. Just think about the amount of work it is to support 2D next generation 911. OneSpatial has been helping organizations get their data fit for purpose using our OneIntegrate product to automate the process to help relieve this amount of effort of this task. However, as many of you are aware, we don't live in a two-dimensional world, and organizations like NENA, the National Emergency Numbers Association, is already forward-thinking with their 3D working group. This presentation is going to focus on how organizations can use our new 3D capabilities to support efforts like NG911, facilities management, transportation, and beyond. We have set up a Mentimeter poll to help us understand where state agencies are with their 3D work and what types of data sets they're working with. Feel free to take the poll during or after our presentation to provide your thoughts. So there's a number of different interpretations as to what 3D data is. Keep in mind, many datasets have had additional dimensions beyond just X, Y, and Z, like adding measure values in linear referencing systems or adding time. While OneIntegrate has supported both time and measure values along with Z for a long time, we're talking about true three dimensions in a more standard way of thinking about it. So let's talk about this in a little bit more detail. Here are different ways data can be described in 2 dimensions and beyond. These descriptions were used from a publication cited below. In Figure A is what we think of as traditional 2D data. It's points, lines, and polygons that represent the world for thematic maps. In Figure B, some refer to this as 2.5D. This is when you drape data over a surface. And Figure C is where we start getting closer to what we start thinking about with 3D. And these are building 3D shapes that are just really extruded 2D features. And then Figure D is getting even closer, where each vertex actually has an independent Z value. However, the feature has no volume. Now, when we get to Figure E, you have true volumetric 3D. And this is where GIS is going to have to go to support true 3D analytics. So let's break this down a little bit further. Before 3D, think 2D. Imagine having parcel boundaries and just the edges. If you want to check for containment, you have to hope that you have clean data that connects, and 2, connect the lines to form a polygon, and then do the comparison. Instead, if you had parcels as polygons to start with, you could compare that much easier. Now let's take this to 3D space. Now instead of having parcel, polygon versus boundary, imagine a building footprint. On the map, having it 2D is fine. You're looking at it from above. But if you want to rotate our perspective and visualize the building, we can give it some height. So we added Z value. That is essentially what 2.5D is, a 2D feature with a Z value. And sure, you can visualize the sides or even the cap off the bottom. Looks good for visualizations and has many uses. It's enough for surface models, for example. However, still has the containment of other feature comparisons that the boundary only model in 2D has. So if we wanted to say a point, say a 911 call, we'd have a lot of computation to find out if that point is in fact within that 2.5D shell. That's where true 3D comes in. Full 3D allows for these sorts of comparisons and more complexity, like if we have overhanging roofs, rooms and buildings, and so forth. All right, so now that we've set the groundwork for what 3D is, let's go into, let's step back for a second. As I mentioned earlier, OneSpatial, we have a background in data management, performing validation, integration, enhancement of the data. We work with many customers on complex data management challenges to support things like data supply chains within spatial data infrastructures or more complex conflation work. One Spatial as a global company has been working on data management solutions for 50 years. And while we are a bit newer here in the US, we are growing very rapidly supporting transportation, utilities, government, and facility organizations. And one of our biggest growth areas more recently is with working with organizations like the state of Michigan, California Office of Emergency Management, the state of Minnesota, the state of Georgia, Arizona, and New Jersey, and helping with data quality and integration of next generation 911 data. Which leads me to the use case that we wanted to highlight for 3D validation and inference. When we think of current addressing, we have an address point that may or may not be within a building footprint. We have done some work on helping organizations update the positional accuracy of their address points to actually be within a building footprint. However, what happens when you have multiple addresses within one building? Organizations manage these situations slightly differently. Some organizations have stacked address points, meaning there are multiple points at the same location with the unit number identified in the metadata. Some other organizations distribute the addresses across the building. By distributing the addresses across the building gives the map viewer a better idea on how densely populated a particular building is, or in some cases, the system just requires the data to be in that format. Our US Census work used this distributed model where we automated the process of equally distributing address points within a building footprint. Now, for those 911 experts out there, I'm sure you're saying, well, none of this affects call routing, and you're right. It would be extremely unlikely that a building would cross over two PSAPs since PSAP boundaries typically follow along roads. However, call dispatch could be affected. You want to make sure that the response team shows up to the nearest available entrance to wherever emergency happens. That's where we can start to look at some as-built CAD drawings and integrate that with the GIS data in order to get an address point in a more realistic location. So let's talk about how we can automate that, and then we're going to talk more about taking this to 3 dimensions. All right, so what we're looking at here now is we're in ArcGIS Pro. We're looking at the GIS data. So I have my building footprint data set, and I have my site address point data set. And that site address point data set is all stacked addresses. So if we select that particular address, we're going to see we have 623 different units inside this particular building. And what we want to be able to do is, instead of just representing this as a stacked addresses, we want to put it spatially where those rooms actually are located inside the building itself. Now, that data is not existing in the GIS, it's existing in the CAD data itself. So let's go to the CAD system and look at the data in the CAD system. So we're looking at our AutoCAD files. So we have one for each floor, building, floor 1, 2, and 3. And if we zoom in, we can see inside that particular CAD drawing, we have information on the room numbers, which should also reference back to those particular address points. Now, what we're going to do is we're going to use the One Integrate product to actually integrate these two different data sources so that we can update the address points to those particular locations. So let's flip over now to One Integrate. And what we're in, for those of you that have not seen the One Integrate application, we're on the Sessions tab. So this is where we can connect to different data sources. We can run a series of business rules against the data, either validate the data or integrate that data source. So I'm going to go ahead and just hit play, and then I can walk through what is actually happening. So what we're doing is we're first bringing in the building footprint data set. That is that polygon. We're going to bring in some of the addressing data, and then we're going to bring in all 3 CAD drawings for those different floors. And then we're going to run it through a series of business rules to update the address points to that particular location where it's located. And just so we can see what we're working with here, let's go take a look at a couple of these data stores real quick. So here is that AutoCAD data store. So I'm connecting to that AutoCAD drawing. It's going to bring in the schema of that AutoCAD drawing, and I can use that to write the rules to update the location. So if we come back over my session, let's show where we're actually moving the address points. So we're coming over here. We're basically saying for a given address point, if the room IDs are the same, move the address point to the particular location. So pretty simple stuff. And then we can write that result out and we come back over to the GIS application. And now we have our address points, but they're actually located where they're particularly at. Now this is nice because we at least know generally where those rooms are located, but this doesn't help us with three-dimensional space. So let's talk about that next. All right, so the main reason we're here today is to talk about 3D data. And so just like the last case that I mentioned before, the same can be said for multi-story buildings. Which elevator or stairwell do you use to get to an emergency? So I pulled this image from a presentation that was given at the 2021 NIDA conference where Richard Kelly, among others, were presenting on this particular topic. They are all members of that the NIDA committee on 3D. And this presentation was talking about the need for 3D data in call dispatch. And I mentioned earlier in the presentation that it is an extremely heavy lift for organizations to get their 2D data in order for next generation 911. So how are organizations actually going to do this work for the 3D? And to be realistic, it is not feasible to do this in a manual way. This is going to have to be automated. So let's talk about how we can leverage One Integrate's 3D capabilities, similar to what we did in the last example, but now let's take this to 3 dimensions. So what we're going to do is we're going to take the GIS building footprint data set, and in there we have some information about the height of the building and how many floors there are. We have AutoCAD drawings that identify where rooms are particularly located. We could load that all into One Integrate and infer where these particular rooms are going to be located using that One Integrate 3D engine. And then we can also, beyond just doing that, we can do additional validation checks to see, did we create any sort of spatial issues within the data set itself when doing this automation work? All right, so just like in the last example, we have this same building footprint data set. If I select that building footprint data set, it's going to tell me the number of floors, and it's also going to give me information on the building height. So I can use that information to infer where the data set is going to, how high is the data set going to be, and how big each particular floor is. And then back to the same thing with the DWG drawings, the AutoCAD drawings, we have that information on where all the actual rooms are located. So we can combine these two different data sets and actually infer what the entire three-dimensional model of the particular facility is located. And then lastly, even we can then technically move our address points into the actual facility location. But in reality, once you get to a true three-dimensional model, CAD system as in dispatch system, you don't even necessarily need those address points anymore. You can just say, well, if the call is occurring within that cubed area or close to that cubed area, you know which room it's actually located in. So let's go ahead and now flip over to the One Integrate product again. And just so we can walk through what's actually going to be occurring here is I now have a couple extra data stores, right? So I'm going to bring in those AutoCAD data sets like I did before. I have that GIS data set. I'm bringing in a Oracle data store. This is where I'm going to write the data out to because I want to have my three-dimensional data written into a system that supports true 3D, which Oracle Spatial does. And so we're going to go ahead and just so let's go ahead and select this particular data store. What you'll notice here is that for those that have One Integrate with the new 3D functionality, which is an extension to One Integrate, you have this checkbox enable full 3D. So this enables you to actually create and generate true three-dimensional data sets. So let's go back over to my session now. And I'm going to go ahead and just fire this off. So we're going to connect to that Oracle data store. We're going to bring in that GIS data set. We're going to bring in those 3 AutoCAD drawings. And then we're going to do some generic cleanup. We're going to extrude the building footprint. So the building footprint now is a three-dimensional feature with actual volumetric information. We're going to take each floor plan and we're going to move that floor plan to where it's actually located in three-dimensional space. And then we'll extrude those. And then we'll do the same thing with the actual room information. And then lastly, just as a just to show you doing true validation too, true 3D validation, is that we're going to move the actual room, the actual address points into each physical room, into the center of the room, and we'll validate to make sure that each room has an address point that's contained within that particular location. So we're doing this for that entire floor plan. This takes about a minute to run for the entire floor plan to do that 3D generalization and then do some additional validation checks. So one of the validation checks saying that there must be an actual address point within a room is about, we're getting a 99% conformance. So there's a few rooms that don't actually have an address point located in them. And then we're going to do some other additional validation checks. So let's see here. And then if we see here, when we talk about the floor contained within the building, we're getting a 0% conformance. And I'll walk you through when we actually visualize this to make it it's a little easier to understand when we actually visualize it. But basically, when we take a CAD drawing and we try to put it inside the building footprint, three-dimensional space, it doesn't exactly fit. So those are things that we're going to have to use some sort of positional accuracy improvement in the future to clean that up. And we can do all that stuff inside of OneIntegrate, we just didn't do it in this particular demonstration today. And then lastly, we're going to make some markups based off of where those buildings didn't actually contain within the floor itself. So let's go take a look at what this actually looks like. So we're going to walk through it inside of OneIntegrate, what we did here. So within OneIntegrate's application, we now have true three-dimensional representations of the data. Oh, I'm going to do that. We have true three-dimensional visualization now too within the OneIntegrate data viewer. So we have, if we come back over, let's start from our beginning of the session, so where we connect to our different data sources. So we have our building floor. We have the CAD data. So we have stuff like the rooms for each floor. So this is the room area for the second floor. We have the rooms for the first floor. We have the floor area. Notice that obviously the floor areas are not the same because, it's not necessarily the footprint of the data set, and they also don't necessarily always align. So these are things that I mentioned before that we're going to have to eventually clean up before, moving this into a production level data set. So we have that. Now we have the CAD information and the GIS information, at least in the same geospatial space inside the engine, so that we can actually do the three-dimensional work now in the data set. So the first thing we're going to do is we are going to extrude the building footprint based off of the height of the data. And now we have a building footprint that's extruded here. So let's see here if we can work on a good angle. The next thing we're going to do is we are in the session, we're going to offset the actual heights of the different floors. So now if I look, my floors should now all be where they're actually located. So now the floors are all where they should be located, but they're still 2.5D at this point. They haven't been actually extruded out. So that's what we do. The next thing we're going to do is we're going to extrude the floor objects. So now when I turn on my floor layer, and let's turn off the building one so we can see what we're working with here. I'll turn off these original CAD 2.5D. So now we actually have 3 floors. Then we could do the same thing with the room objects. So when I come over back to my legend now, we now have, we now have actually all of our rooms in three-dimensional space. What we also do is we do have columns and so forth in these CAD drawings, so we could even extrude out those columns too. Now what's interesting about the columns is when we extrude those out, and if I look at the data set, we're going to notice that things don't necessarily align quite right, because between those two different CAD drawings, they weren't exactly aligned. So some of the work that we're actually doing for Google right now is making sure that for each individual CAD drawing, as you stack them up to each other, that the different elevator shafts line up, the columns line up, the stairwells line up the way they're supposed to. So doing that alignment for multi-floors within those CAD drawings. So we're working with Google doing that so that you don't have things like this occur when you're trying to bring in, the columns. We're trying to make a three-dimensional representation of the columns and so forth. And then what we also have, let's go back over here, is we also have the address points too that are also now in three-dimensional location. So all the address points are actually within the rooms themselves. And the main reason I did this is more so to say, well, if there was a call that came in from one of these particular locations, you now can do a check to say, is that particular call within that particular room? And then what we did is we also cross-referenced now all these different address points with the actual 3D spaces to make sure that any given space has an address point. And if we come over here, we found there was 2 rooms that didn't actually meet that. So here we have an address point that doesn't have a particular location at all. And actually the reason why is because it has parentheses inside the room number. That's why it's not matching. And this is another example here where there's parentheses. If there weren't parentheses in that particular room number, it probably would have found a match. And the last thing we did was we did the saying a floor must be contained within a building. So, and in this case, we have all of our, let's go back out real quick. All right, so we have the floors in the buildings, and we can do a validation check to say that the entire floor is contained within the building footprint. And what we find is that when we do so, none of the floors actually align. And that makes sense because, some are built, they're all built in AutoCAD, and there's other data sets in the GIS. So there's obviously some transformation issues that need to be addressed. But beyond just doing that validation check, we can also do a markup on identifying where those particular overlaps are occurring. So let's go back over to my session, and let's now do that where we mark it up, and let's turn on that markup, and let's turn off the other layers so we can see where all these particular slivers are located at. So these are all the different slivers on where the actual building doesn't contain the floor, or the floor is not contained within the building itself. And all that, just like we could do a point markup, we can also mark that up on the building thing. So we can automate the process of generating these three-dimensional features. Not only that, we can also validate that objects are actually contained within those volumetric information. So doing those volumetric validation checks is something we can also do now within OneIntegrate. So let's go back over to the slide deck. So as I mentioned before, we automate that process of doing that 3D generation, leveraging OneIntegrate. So we can extrude the buildings out, extrude the levels out based off of the metadata that's inside the building footprint, also leveraging the AutoCAD information, and then use that to create these three-dimensional models. Now, these three-dimensional models can be used for next generation L1. They can also be used for facilities management, among other use cases. And actually, that's where it leads us to close out, is that this may not necessarily be something that your organization is either ready for or interested in on that next generation. Now, one side, but are there other 3D use cases that could be valid? And that's what we would like to know, because this can also help us gear where we're going to put our development resources in, is to know what types of use cases where true 3D validation and inference and integration could be useful for you. So if you would be more than happy to take that to do the Mentimeter poll that we set up in the beginning, and I can also, I'm available for questions post this presentation, so reach out to me if you have any sort of questions. Thank you very much, and you have a good day.